In every chapter, we will study I. But in maths also, I will make everything complex. Correct or not? So in chemistry also, this I makes it complex. Right? So we will study about I and half and. Right? So this is the flow of chapter. Right? Now I will start with first topic. What is it? What is it, sir? Solubility of gases in liquids. Solubility of gases in liquids. Instead of calling this as gas, can I call this as more volatile solute? Can I call it? You know solution. You know what is solute, what is solvent, right? Online, someone respond. You know what is solute, what is solvent? What is solute? What is solvent? What defines solvent? What is solvent? Huh? What is solvent? Ayyo. I thought you know everything. That's why I skipped that methods of expressing concentration. Define solvent. Or if I mix salt and water, you got some salt solution, saline water, which is solute, which is solvent. Why water is solvent? Oh, it dissolves. That's why it is solvent. Okay. Then listen. I have taken pearl. Okay, I have taken ruby crystal, ruby, right? In ruby crystal, gemstones, in ruby crystal, which is solute, which is solvent. I have taken steel rod, in steel rod, which is solute, which is solvent. Okay, in this wall, which is solvent, which is solute. In air, which is solvent, which is solute. Respond. That means there is some condition to say something as a solvent, correct? Yes, I want that. What is solvent? Someone is giving some information. Huh? Salt is solute. Huh? Okay, sir. Salt is solute. Okay, accepted. Why you called salt as a solute? Listen, sir. Class 8th. I am going to discuss. Class 8th topic. In class 8th, one topic is there. Homogeneous mixtures, heterogeneous mixtures. It is there or not? Yes or no? Right? I am coming there. That also I need to explain. Only not directly I am coming to conclusion there, right? So when I mix something, I call it as the obtained resultant thing as is a mixture, right? And whatever the things I am mixing, we call them as components. So I am mixing 2 or more components to form a mixture. Then the mixture can be 2 types: homogeneous, heterogeneous. Correct? So when the components are mixed uniformly, right, throughout volume, if they are of same composition, if they are distributed uniformly, then it is called homogeneous mixture. If they are not distributed uniformly, then it is called heterogeneous mixture. Right? Now I am talking about homogeneous mixture. Means, or if I add salt and water, the salt will be distributed uniformly throughout water or not. That's why I call it as homogeneous mixture. Right? So I have taken component 1. Hey, don't write, man. Waste this is. Huh? Component 2. I mixed them. Then I got one homogeneous mixture. I am not writing any definition of homogeneous mixture now. Reason? Reason, sir? What is homogeneous mixture? Why I call as homogeneous mixture? uniformly distributed. Uniform distribution of both components. Correct, sir? Response, sir. How many components I have mixed? That's why I call it as binary mixture, or I call it as binary solution. Ternary solution means I need to mix 3 components: quaternary, polinary, right? I am bothered about only binary solution. So I am mixing. One second, we keep at one of the rack. 1 second. I am talking about something. So if I am mixing many components, then it is polinary. So I am talking about only binary solutions now. Very simple. Only 2 components I am mixing. If 2 components are mixed uniformly, then it is homogeneous. They are not mixed uniformly, heterogeneous. Right? Sand and water, heterogeneous. Sugar and water, your favorite drink. Ethyl alcohol plus water, homogeneous. Right? Correct, sir? Now, I can call this homogeneous mixture as solution. I can call this as solution, and I call this solution as binary solution. Will you understand why I call it as binary solution? Why I call it as binary solution? Because I have mixed only 2 components. That's why I call it as binary solution. That homogeneous mixture is now called as binary solution. Now, if a solution phase means we have 5 phases. What are they? We have 5 phases. What are they? Solid phase, liquid phase, gaseous phase, plasma phase, Bose-Einstein condensate phase. Then how many states are there? What is the difference between a phase and a state? This is the first thing I told you about the chapter gaseous state. We discussed one chapter, na? Gaseous state. In class 10th also it is there or not? Gaseous state. Okay, states of matter. You studied it or not? Why they call it as states of matter? They are not calling it as phases of matter. They call it as states of matter. There is a reason, na? Why it is called as states of matter. Okay, what is this state? Okay, what is its phase? Then why 2 different words? Phase represents physical form. State represents energy. Wherever you use your word state means you are talking about energy. Right? Now, which is the lowest energy state? Bose-Einstein condensate state. You studied it or not in your earlier class? You call it as Bose-Einstein condensate state. If I increase the temperature of it, then it converts to solid state. If I increase energy further, it converts to liquid state. Right? If I keep on increasing energy of liquid keep on increasing. All these different energy states of liquid are all states, different states. After reaching certain state, it is no longer liquid state. Now it becomes gaseous state. If I keep on increasing energy of gas keep on increasing. After reaching certain state, it is no longer called as gas. It is called as plasma. Are you able to understand? So state is a energy parameter. Right? Now I have taken one solid. It may have different energies. All that energy states put together, it is in one physical form. That physical form is called solid phase. Right? In solid phase, if I have taken a rock, it is in solid phase. In solid phase, infinite energy states are possible for it. And if I keep on giving a little energy, its energy rises. So it is state change. Again, if I give more energy, are you able to understand? All those energy states put together, it will be in one physical form. That physical form is called solid phase. Correct? Now, if I keep on giving energy, at certain point, it starts melting. When it started melting, it is converting into another phase. When it is converting one phase to another phase, there will be one phase boundary. Correct? One phase boundary is there. That phase boundary which it distinguishes this is liquid, this is solid. I have taken ice, man. I kept ice here. Can you see something amount of water formed around it? So we can able to see it. This is liquid, this is solid. Are able to identify this is the border for it. Boundary we can distinguish. When I am able to distinguish the boundary between them, then it is called as a phase boundary. Understood? Any questions in it? Right? Now I am talking about only liquid phases. Right? Or I am talking about liquid state. Correct or not? Means whatever I am taking, everything will be, my final system will be always liquid. That's why solubility of gas in liquid, solubility of liquid in liquid, solubility of solid in liquid means always my final thing is liquid only. Correct? Any questions in it? Right. Now, the phase of solution. See the phase of solution, right? And the phase of components. The component which is in the same phase as that of solution is called solvent. Are you able to understand? Solvent means component which is in same phase as that of solution. Right? That component is called as solvent. Obviously, the other component is called. Now tell me, salt plus water gives saline water, salt water. Now, why I called water as solvent? Solution is liquid phase. Water is also liquid phase. That's why I call it as solvent. Now we should raise a question, sir. Our favorite thing. Ethyl alcohol is liquid. Water is also liquid. Now I mixed them. I got solution. Now tell me which is solvent. Because solution is liquid, my both components are also liquids, then which is solvent? Now the condition, if all the components, if all components are in same phase, as that of solution, then the component which is in excess quantity. Now we will talk about quantity. Which is in excess quantity is called as solvent. Now you know what is solvent, right? Respond. Now you know what is solvent or not? Obviously, now you know solutes. I have mixed many components. I have taken a polynory solution. Right? I have taken a polynory solution. In that polynory solution, how many solvents are there? How many solutes are there? Or I have taken water. I added sugar. I have added salt. I have added ethyl alcohol also. Now I have added some lemon also. I have added some cool drink also. Now I have fixed one peg. Now tell me, what is this solution? In this solution, what is solute? What is solvent? Right. Now, solvent is unique. Means irrespective of any number of components you mix. Only one component is a solvent, remaining all components are, right? Now tell me, air is a mixture of many gases or not? Whether all gases are mixed homogeneously, uniformly throughout volume or not. Correct? Now, this is a solution or not? Air is a mixture of all different gases, right? Atmospheric air. Ah, yes, of course, that is gravity. Gravity is keep on changing it. If gravity's influence is not there properly, then it is a homogeneous mixture, right? Now it has a oxygen, carbon dioxide, nitrogen, everything, right? So assume it is a polymery solution now, correct? All are in same phase. What are their phases? Gaseous phase. Air is also gaseous phase. Now tell me which is excess in quantity. So which is solvent in air? Nitrogen is solvent, then oxygen is solute. So we are surviving on solute. Correct or not? Respond, sir. Now I have taken a steel rod. Steel rod is also homogeneous mixture of iron, carbon. And in order to increase the strength of iron, we will mix carbon. We will decrease the composition of carbon from 4% to 1.5 to 2%. Then it is called stainless steel, right? So in stainless steel, majorly it is composite. Major components are iron and carbon. Now which is solvent? Iron is solvent. So steel is solution. Correct or not? Carbon is solute. Now tell me, the moment I say solution, always in your mind, you will get liquid. Yes or no? Mistake. Solution can be either in liquid phase or solid phase or gaseous phase. So what is the solution? Homogeneous mixture of solvent components is called solution. The component which is in same phase as that of solution is called solvent. Remaining all called as solutes. Respond. I have taken anhydrous copper sulfate, CuSO4. What is the color of it? Anhydrous copper sulfate. Color. Colorless. Anhydrous without water. So CuSO4, only CuSO4, white color solid. Now I have added 2 to 3 drops of water. Now it turns to blue. Right? Now tell me that a CuSO4.5H2O is mixture or not? Because I mixed it. Correct or not? In that, every CuSO4.5H2O means every copper sulfate is equally distributed with 5 water molecules each. Means it is a homogeneous mixture. Now tell me in that which is solvent? Which is solvent? Copper sulfate. Reason CuSO4.5H2O is blue color solid. Correct, sir? CuSO4.5H2O is, I'm writing CuSO4.5H2O is blue color solid. How I got it? By mixing CuSO4 solid anhydrous, correct? And I have added sufficient amount of water, which is a liquid, to form this. Correct? Now, what is the composition? What is the phase of it? Solid. Now, among these two components, which is solid? So that is called solvent. Now, what is solute now? Right? Someone said water is universal solvent. Who is that fellow? Now I made water as solute or not? Respond, sir. Right? Of course, I will accept that statement. Water is universal solvent because it can dissolve. Almost most of the salts are soluble in water. That's why it is called as universal solvent. Right? But I can create the situations where water can act as solute. Any questions are in it? Any doubt about solute and solvent? Now, I have added 50 ml ethyl alcohol. which is liquid, mixed with 50 ml water, which is also liquid, to form alcoholic solution. Okay, or aqueous solution. Now tell me, which is solute, which is solvent? Say something, which is solution, man, which is solute, which is solvent now. Which is solute, which is solvent. It is mandatory. When you name a solution, you need to name the solution on behalf of the solvent. If I say it as aqueous solution, means I am assuming water as a solvent. If I say it as alcoholic solution, means I am assuming alcohol as a solvent. So the moment you say it as alcoholic solution, means I am assuming alcohol as a solvent, water as a solute in it. If I call it as aqueous solution, water as a solvent, alcohol as a solute. Sir, instead of 50-50, if I give 60 and 40 here, then obviously it must be alcoholic solution. You should not call it as aqueous solution because you defined the volume, which is excess in quantity, is fixed now. If I give 40 here and 60 here, obviously it is aqueous solution. Problem rises only in this case. When both are equal, your choice, user's choice. Right? Are you able to understand? If I am interested in this, alcoholic, aqueous. Any questions, sir, in it? Clear or not? So you now know about what is solution, right? Respond, sir. Now we are talking about solutions. So now I am not going further. I am coming back to our old concept, right? Solubility of gases in liquids. The moment I add gas to liquid, what is the final phase of the thing obtained? I am passing carbon dioxide into water, soda water, or a cool drink, soda water, right? So I am passing carbon dioxide into water. So what is the final phase? Liquid. So which is solvent now? Water is a solvent. Therefore, gas becomes. That's why I call it as more volatile. So, sir, why you call it as more volatile? And it is gas, man. Gas means the component which you will convert into vapor readily. That is called gas, no? That exists as gas. Correct? Respond. Now here, I call this liquid as relatively less volatile solvent. Right? So instead of saying it as solubility of gases in liquids, if you want to say it as more complex, no one should understand it, then I will say it as solubility of more volatile solute in a less volatile solvent. Indirectly, we are talking about solubility of gases in liquid only. Right? Technically, we have to call it as solubility of more volatile solute in a less volatile solvent. Till now, we have not yet started the chapter also, not yet started anything. Right? We are discussing about why I have wrote that in that way. Right, sir? Shall we start? Right. Now, before starting it again, point 1. How I can make gas to dissolve in water? How I can make gas to dissolve in water? Pressure, by applying pressure. That's what, or if you go to vendor, he will keep one cool drink bottle, he fill it with water, he will keep inside. Freshly, he will prepare soda water, some salt, lemonade, and he will give it, adding some ice cubes to it. Correct, sir? Freshly prepared soda water, like a lime juice, freshly prepared lemonade. Correct? So what he is doing? By applying pressure, he is trying to dissolve gas in liquid. So on increasing pressure, what happens to solubility of gas in liquid? On increasing pressure, solubility of gas. Will you understand if I write like this? In liquid increases. But here rises one problem. Have you identified any problem? Listen, I have taken carbon dioxide gas inside a cylinder. Pressure is 10 atmosphere. So carbon dioxide gas at 10 atmosphere. Now I am applying pressure over it. 10 to 15, 20, 25, 30, 100. At 100 atmosphere pressure, do it carbon dioxide as gas or it will convert into liquid now? If I keep on increasing pressure, what happens to gas? Gas will slowly convert to liquid. Reason? And I am applying pressure means I am pushing gas molecules close to each other. If I push gas molecules close to each other, what happens? They will start attracting. Right? Van der Waals interactions will start. So if they start attracting, they will convert into liquid. If that attractive forces crosses certain limit, they will convert into solid. Because I am decreasing volume. Correct or not? So if I keep on increasing pressure, what happens? Solubility of liquid, gas and liquid also increasing. But there is a problem. What is the problem? After a certain point, it becomes solubility of liquid in liquid. It can't be solubility of gas in liquid now. Correct or not? Because when I am increasing pressure, gas will convert into liquid. If gas converts into liquid, I will be studying liquid in liquid. But what is the heading? Means my gas must be gas only, my liquid must be liquid only. Means to what extent I can increase pressure? I cannot increase pressure as I wish. I will increase pressure only to certain extent. I should not increase more. Correct or not? So condition. What I will write? But not very high pressure. Will you understand, sir, why I am saying that statement? But not very high pressure. Reason? Are you able to understand why I am writing this statement, but not very high pressure? Clear or not? Any questions in it? Now, what about on decreasing temperature? If I decrease temperature, do gas molecules come close to each other or not? On decreasing temperature, if I am cooling it, do gas molecules come close to each other or not? I am decreasing temperature means I am removing energy from it. If I remove energy, do gas molecules move vigorously or they move slowly? If I decrease energy, what this air filter is doing? It keep on decreasing temperature or not? When it decreases temperature, what happens to energy of gas? Then gas will move slowly because its kinetic energy decreased. If they are moving slowly, this is one gas molecule, this is another gas molecule, right? Assume this is one magnet, this is another magnet. So I have two magnets. When I'm moving both magnets one above other very quickly, do they attract? What happened? Do they lost magnetic property? Then why they are not attracting? Are you able to understand my question? I have taken one magnet and I am moving another magnet over the surface of it, right? Very quickly. What happened? Whether they attract or not? No. Reason? Contact time. To experience attractions, people require some contact time. Correct or not? Otherwise, how can you attract, man? Minimum, you need to spend some time with others. Then only you can attract them. Understood or not? So that contact time is required. As we keep on increasing energy, as they are moving vigorously, contact time decrease. Therefore, even though they have the efficiency to attract, as contact time is less, they contact. If I decrease temperature, I'm decreasing energy, I'm decreasing its velocity, kinetic energy means I am decreasing velocity. Then what happens to contact time? Then what happens? Gas molecules attract. Correct or not? Respond, sir. So what I am doing? On decreasing temperature, what happens, sir? Contact time increases. Gas molecules attract each other, right? Or simply attractions increases. If attractions increases, what about attractions between gas and liquid also? Increases. Then solubility of gas and liquid also. So solubility of gas in liquid increases. Any questions, sir, in it? Again, there will be a problem. Reason? Why I'm writing, but not very low temperature. Reason, sir? Phase will change. If I keep on decreasing temperature, gas now may become liquid, or this liquid may become solid. Right? If they are changing their phase, I cannot study them. So temperature you decrease, but not decrease very much. Pressure you increase, but not increase very much. Clear? Now, based upon these two statements, can I make one conclusion? You try to increase the solubility, but not very high solubility. Can I say that statement or not? I am increasing solubility, right? But I should not increase pressure much, but I should not decrease temperature much means I should not increase solubility much. Correct or not? Response, sir. Clear? Any questions in it? No. Leave that aside. Now I am taking third condition. Third condition, sir. In gaseous state chapter, you heard something about critical temperature. What do you mean by critical temperature? Don't say TC. I know that. Critical temperature is TC, which is equal to 8A by 27 RB. I know that. Right? Critical temperature. I am asking, what do you mean by critical temperature? What do you mean by it? Are you really following me or not? What's that? What do you mean by critical temperature, sir? Yes. What do you mean by critical temperature? Listen. Listen. In this room, it is filled with air, correct? Right? If I keep on increasing pressure inside this room, what happens to distance between gas molecules? Means attractions. If I keep on increasing pressure further and further, at some point, this gas may convert into liquid. Acceptable or not? Means on increasing pressure, at certain pressure, gas will start converting into liquid. Now, what I am doing is, I will keep on increasing pressure. At the same time, I will keep on increasing temperature also. If I increase temperature, what happens to energy of gas? Energy of gas increases. Then velocity. Then what happens to contact time? If a contact time decreases, what happens to attractions? Decreases, no? Then what happens to the ability of gas to convert into liquid? So I am increasing pressure, so it should convert into liquid. As I am increasing temperature also, it will not convert into liquid. Correct? Respond. Correct or not? Now, I keep on increasing pressure and I keep on increasing temperature. Okay. After reaching certain temperature, whatever may be the pressure you apply, gas will never convert into liquid. That temperature is called critical temperature. Are you able to understand? Critical temperature means temperature above which irrespective of any pressure, whatever, even if you apply infinite pressure, gas will never convert into liquid. Below that temperature, if I keep on increasing pressure, at certain pressure, gas will convert into liquid. If you cross critical temperature, whatever you do, it is impossible to convert gas into liquid. Is it clear? Understood or not? Now define what is critical temperature. The temperature above which it is impossible to convert gas into liquid at any pressure. It is called critical temperature. I am writing that point. Critical temperature means temperature above which gas cannot be liquefiable at any pressure. Any questions are in it? Mathematically, you got that 8A by 27 RB from Van der Waals equation, right? By applying the condition. What is the condition? We got one and two isotherm graph, right? After getting that graph, we have applied one law, one principle, point of inflection. What is point of inflection? For a maths man, if you get any curve, what is point of inflection? What is maxima? For any curve, what is maxima? Differentiation of that way, that curve equation will become equal to 0, and its double differentiation becomes negative. Minima differentiation is 0, but its double differentiation is positive, right? Correct or not? When double differentiation value is 0, then it is called point of inflection. Respond. Correct or not? So by applying point of inflection, we derived and calculated PC, VC, TC, ZC in states of matter chapter. Okay, it is not required now. Leave that. Now coming to this. For a particular gas, critical temperature is high. What is the meaning of it? For a particular gas, critical temperature is high. What do you mean? What is the meaning of it? Means up to that temperature it can convert into liquid. For a particular gas, critical temperature is low. Means critical temperature is low. What is the meaning of it? At low temperature itself, it cannot convert into liquid. For a particular gas, critical temperature is high means what is its ability to convert into liquid? High. Critical temperature is high means up to that temperature it can convert into liquid, means its ability to convert into liquid is more, means its ability to have molecular interactions, attractions is high, right? Now tell me, in order to make solubility of gases in liquids to increase, what type of gases I have to select? What type of gases I have to select in order to increase solubility of gas in liquid? Critical temperature of gas must be low or high? Think, come to a conclusion. Tell me. Low or high? So what should be the condition? High. If a critical, listen man, common sense man, listen. Critical temperature is high means what is the meaning of it? It can convert into liquid easily. If it is converting into liquid easily means it can dissolve in liquid easily. Means attractions are high. Attractions are high means that gas can dissolve easily, na? Means a gas with a higher critical temperature is soluble readily. Correct or not? Understood? If critical temperature of gas is low, means at any pressure you cannot convert that gas into liquid. Means at any pressure you cannot bring attractive interactions. If you are not able to bring attractive interactions, means it remains as gas only. Means its solubility in liquid is low. Clear? So I am writing that point to avoid confusion. Gases with high TC are readily soluble. Clear? Gases with high TC are readily soluble. Will you accept this statement? Or can I say gases with good molecular interactions, or can I say gases with more dipole moment? Dipole moment means net positive one direction, net negative one direction. Then such gases, if I bring closer to each other, they attract each other. Then they are readily soluble. Correct or not? So gases with good molecular interactions. Good molecular interactions are readily soluble. If molecular interactions are good, means their van der Waals constant A is high. If A is high, means TC is high. If a TC is high, means readily soluble. Clear? Any questions in it? Clear or not? Now I will start the chapter. Till now I have not yet started the chapter. Right, sir? Okay, huh? Now listen, sir. What I told you about Henry's law. Henry's law is applicable for solubility of gases in liquids. Now tell me, in order to study about solubility of gases in liquids, do the solubility of gas must be very high or it should be low? Low. Reason? I told you the condition. Because if solubility is high, definitely it will change its phase also readily. If it is changing its phase readily, I cannot study it. Right? Means if I want to study about solubility of gas in liquid, or if I want to apply Henry's law is applicable only for sparingly soluble gases. Sparingly soluble gases are the gases which have more gaseous behavior than molecular interactions. Are you able to understand? Or the gases have more ideal behavior than molecular interactions. Clear? Such as hydrogen, nitrogen, oxygen, helium, etc. Methane, etc. Will you understand? Henry's law is applicable for sparingly soluble gases. Means gases like hydrogen, nitrogen, oxygen, helium, methane, etc. in water. Right? It is not applicable for solubility of HCl gas in water. Reason? Why I am not studying solubility of HCl in water, solubility of ammonia in water? I will not study. Reason? Molecular attractions are high. The moment you bring water, ammonia readily converts into liquid. then how we will study about solubility of gas in liquid? Right? At the same time, the moment I dissolve ammonia in water, it is no longer ammonia, it converts into ammonium hydroxide. HCl gas, when it dissolved in water, it is no longer HCl, it converts into H plus and Cl minus. It ionizes. Means Henry's law is not applicable for, that is, Henry's law is not applicable it is not applicable. In which cases it is not applicable? If gases ionize or react, right? Or ionize, or I call it as dissociate, right? Etc. Or instead of saying interact with solvent. See, if this is happening, Henry's law is not applicable. Example, HCl gas, ammonia gas, etc. Their solubility in water in this case, Henry's law is not applicable. Any questions, sir? Do you have any questions in it? Online? Anyone alive, awake? Do you have any questions?
No, sir.
Right?
Sir,
Yes, sir.
sir, I didn't know we had class today, sir, so I only joined now. Can you
Very
just
good.
show what you explained so far, sir?
This is what I explained so far. Ah,
One
Now,
page, sir.
in order to make Henry's law applicable, at what pressure I need to study it? High pressure or low pressure? At what temperature I need to study it? Not very high. We will say at not very low temperature. Henry's law is applicable at not very high pressure. And what about TC? Henry's law applicable for the gases whose the TC is low. High means readily soluble. Low means not soluble. Means these are the gases with lower TC. These are the gases with high TC. For high TC gases, Henry's law is not applicable because solubility is high. They will react, they will dissociate. Hydrogen bonding is possible. Correct or not? In such cases, Henry's law is not applicable. Understood? Any questions in it? Clear now? Right. So, I am writing that condition, sir. TC of gas must be what it should be? Must be low. What about temperature? Temperature of gas. Response, sir. Temperature of gas must not be very low. Understood? Why I wrote it? Pressure of gas must not be higher, not be very higher. Must not be very high. Gases should not interact or ionize in solvent. If these four conditions are satisfied, then I can apply Henry's law, right? If a gas is obeying all the four conditions, then I can apply Henry's law. Now, Henry's law, what is Henry's law? If I increase pressure, what happens to solubility? Increases. So I'm writing the same. On increasing pressure, if all these conditions are obeyed, then on increasing pressure, will you understand now if I am writing in this way? If all these conditions are obeyed, then on increasing pressure, now what happened? Solubility of sparingly soluble gas. Are you able to understand why I'm writing it as sparingly soluble gas? Why I'm not simply saying solubility of gas? They would understand, because Henry's law is applicable if and only if solubility is low. If this solubility is high, we cannot study it. Clear? So on increasing pressure, solubility of sparingly soluble gas. What happens? Sparingly soluble gas increases in a given solvent. I am writing in brackets liquid. Will you understand? Any questions do you have in this? Right? Solubility is increasing means, can I say number of moles of that gas in liquid is high? The solubility of gas is high means amount of that gas, number of moles of that gas in liquid is also high. Means what happens to its mole fraction in liquid? Increases. Correct? Are you able to understand? On increasing pressure, solubility of gas in liquid is high. What is the meaning of it? That gas dissolved in water means number of moles of gas in liquid is increasing. Number of moles is increasing means what happens to mole fraction? Increases. So I am writing that statement. That is Na or XA increases. What is Na or what is XA? What is XA? Mole fraction
Sir,
of
mole
gas
fraction.
in. Mole fraction of gas in liquid. Correct, sir? Mole fraction of gas in. You don't get confused, huh? Mole fraction of gas in solution. Will you understand, sir? Mole fraction of gas in solution. Or what is Na? Number of moles of gas in. Number of moles of gas in. Response, sir. Oh, okay. In solvent. No confusion, na? Clear or not? Any questions in it? Therefore, can I write PA? What is PA? Pressure applied on that gas, or I call it as partial pressure of the gas, is directly proportional to mole fraction of the gas. Can I say it? If I apply more pressure over the gas, then that gas is soluble in liquid more. Therefore, mole fraction of that gas in liquid is also more. Correct? Response, sir. What is PA? Partial pressure of the gas. Respond. Any questions in it?
No, sir.
Now see this. Can I remove this proportionality and can I write any proportionality constant? So I am writing it as PA equal to proportionality constant K into mole fraction of A, or I will write proportionality constant KH into mole fraction of A. This is called as Henry's law. Is it easy one or not? Henry's law. Do you have any question about any statement in Henry's law? Right? This KH is called Henry's constant. That KH is called Henry's constant. Now tell me, sir, what are the units of KH? What are the units of pressure? Atmosphere. What are the units of mole fraction? No units. Then what is units of KH? Atmosphere. So KH has units as the top pressure. So under Henry's constant, I am writing ATM. Will you understand? Any questions are in it?
No,
Response,
sir.
sir. Response, sir. Do you have any questions in it?
No, sir. No, sir.
Now listen very, very carefully. To be mathematically derived that Henry's law are based upon theoretical information we created it. Based upon theoretical common sense, we created it. Such laws are called as empirical laws, empirical formulas. What we call this? In generally we write as empirical formula. Na? Here also we call it as empirical relation or empirical law, right? Based upon basic information, we created one formula, then it is empirical. Clear? Any questions in it? Sir, I am studying about pressure and I brought relation between pressure and mole fraction and I created it. If someone I don't want to bring relation between pressure and mole fraction. I will bring relation between solubility and mole fraction or solubility and pressure. If I increase the pressure of a gas, what happens to its solubility in water? Therefore, can I write this? Can I write like this? Solubility of gas is directly proportional to partial pressure of gas. Can I write? Is there anything wrong in it? Meaning is same only, na? On increasing pressure, solubility increases. Therefore, I am writing solubility of gas is directly proportional to pressure of gas. Nothing wrong, no? So I am removing this equal and I will write is equal to that proportionality I am removing. I am writing is equal to proportionality constant KH prime. Now, what is KH prime? Henry's constant only. Array, what I told you, it is empirical relation. Empirical relation means based upon my interest, based upon my way of studying it. That formula got created. Correct? Are you able to understand? So, what is this KH prime? Also Henry's constant. But this Henry's constant is different from the Henry's constant what we have derived earlier. What is the difference? Units. If Henry's constant units is given as atmosphere, then you need to follow PA equal to KH into mole fraction formula. Now tell me what are the units of Henry's constant in this? What are the units of solubility? Moles per liter. What are the units of pressure? Atmosphere. Then what are the units of KH? Moles per liter per atmosphere. Any questions, sir? Or can I write gram per liter per atmosphere? Can I write it or not? Respond. So in any question, they gave Henry's constant KH value. Without seeing the units of that KH, don't blindly solve the problem. Reason? Based upon the units, you need to select the formula. You need to design the formula. See the units of it, design the formula, solve the problem. Clear? Any questions, sir? Right? I am bringing one more relation, sir. I am writing solubility of gas is equal to KH double prime into mole fraction of the gas. Can I call it as Henry's law or not? Response, sir. Can I call this as Henry's law or not? It is also Henry's law. Reason? If I increase solubility, mole fraction of the gas in liquid also increases. Correct? Then this is also Henry's constant. But what are the units of this Henry's constant now?
Sir, mole per liter, sir.
Mole per liter only or gram per liter only. Response, sir. Right? So without seeing units of KH, don't come to a conclusion. Understood, sir? Any questions related to this? Right?
No,
So
sir.
I am writing that
No,
statement
sir.
here, sir. I am writing that statement. Units of KH depend upon the empirical relation expressed. Which relation you are expressing, based upon that your relation, your units will depend. Right? So now see this. Oh, what happened? Now simply I am writing Henry's constant. For the same gas, different scientists will give different Henry's constant values. Why so many people are giving so many different Henry's constant values? Even if temperature is same. Because their study is different. Some scientist is studying by bringing a relation between pressure and mole fraction. The another scientist will study by bringing relation between solubility and mole fraction. The another will study by bringing relation between solubility and pressure. It's my interest because it is empirical relation based upon experimental observation. We created a formula. When you create such formula, by directly units also will change, right? So simply I'm typing okay, yes, sir. Yes, sir. Yes, sir. Okay, yes, sir. Yes, sir. Yes, sir. Oh, okay, okay. Okay, okay. Right. Okay. Yes, sir. Okay, yes, sir. Sir, actually, Right. What I told you. Now I am going to search in internet what? Henry's constant values. Right? Values. We will see one table. So some syntax error. If they give syntax errors, what I will do? You, I am not able to open it. What I have to do, ma'am? NCR, do we have different values? No, they have given only one value, only one KH value. No. That depends upon temperature. 290, 298, different temperatures. But I want at same temperature, different values. Here, to some extent, please. To some extent, I found some table. Observe, sir. Henry's constant. Observe what they have given. Mole per meter cube per atmosphere, or per Pascal. Not visible, huh? It is not increasing, man. I will do one thing. I will copy this image here. Now I will increase the size. Now, done. All these are Henry's constants only. But observe the units carefully. Different units are there or not? Based upon the type of unit you have taken, its value changes. Observe here. The meaning of this table. What is Henry's constant value if units is moles per meter cube per Pascal? Means indirectly moles per liter per atmosphere. Correct? Moles per liter per atmosphere, na? Instead of Pascal, I can use atmosphere, right? If here also moles per liter per atmosphere, observe if here both units are same. When both units are same, what is the ratio between these two? That's why they gave 1. Are you able to understand? Now observe what are the units here. Molar per atmosphere. So means I am converting these units into these units. Then what happened to Henry's constant value? Changed. Now, if I keep on changing that in that way, do the values keep on changing or not? Based upon the unit, you will have different values of KH. Understood or not? Any questions are in it? Same way here. What are the units here? Mole per atmosphere. Here also mole per atmosphere. Therefore, what is this value now? Mole per kg per Pascal. Here also mole per kg per Pascal. Are you able to understand? Comparison, man. When both units are same, their ratio becomes 1. Here also, moles per kg per atmosphere. Mole per kg per atmosphere. Right? If I change the units, KH value changes. Why it is changing? Because it is an, what is it? It is an empirical relation. Clear? Understood the statement? Now shall I close it? For our level, not necessary. But keep this in mind. If I want to prepare any question which is tough, what I will do? I will play with units. Right? I will give A, B, C, D options. Right? If you apply P equal to KH into mole fraction, you will get some value. That value I will give it as A option. But KH units I will change. I will give you another answer. If you blindly follow the formula without seeing units, you will always get answer. You will mark it as correct, but obviously it will be wrong. Clear? We can create it or not. So you must be cautious. Any questions in it? Online, do you have any questions in it?
No, sir.
Response up.
No, sir.
Now, under note, I am taking point number 3. What is point number 1 and 2 says? KH units are not fixed. They keep on changing. So keep an eye on the units of KH. That is the conclusion from point 1 and 2. Now I am coming to point number 3. In your NCERT, you told no, one table just now. Where is that NCERT table? NCERT. Yeah. I have to crop this image, I think. Huh? They took this image from mobile. How can I crop it? Understood. I will do like this. Now, Sauda, observe this table carefully. Observe the units of KH. Observe the units of KH. What are the units of KH? Units of KH, man, kilobar. Units of KH is kilobar, means a 10 cube bar. Correct? So, what are the units of KH? Pressure units. A kilobar means a 10 into 10 cube bar means pressure units only, na? So, KH is having pressure units means which formula they might have taken into consideration according to NCERT. So, according to our syllabus, we have only one formula for Henry's constant. What is it? PA equal to KH into XA, because KH units they have fixed. Correct? So I am marking this and I am writing PA is equal to KH into XA. Do you have any questions now? No questions now? Based upon units, I have fixed the formula. Response, sir. Do you have any queries related to this online? No, no?
No, sir.
No.
No,
Observe
sir.
this table carefully. Observe this table carefully. I am studying about nitrogen gas. See the values of nitrogen alone. Don't worry about remaining all. See the values of nitrogen alone. One value they gave 76.48. Here, man. This one. I am observing these values. Same way, oxygen values also. What difference have you observed? Temperature changed from 293 to 303. Then KH increased or decreased? Wait, observe carefully. On increasing temperature, what happens to KH value? On increased temperature, what happens to KH? If I increase temperature 293 to 303, KH increased or not? So I am writing the same statement, sir. On increasing temperature, KH, what happens, sir? KH. Say something. KH increases. But already you know one thing. If I increase temperature, what happens to solubility? Solubility? So I am writing the same. Solubility of gas decreases. Now tell me, if solubility of gas is high, what happens to its KH value? Done? All of you signed? Attendance sheet, man. Those who have not done, complete it. 2 minutes. So we are discussing something. What? On increasing temperature, KH increased, solubility decreases. We know these two. Now tell me what is the relation between solubility and KH now? Inverse relation means if I increase solubility, Henry's constant will be decreased. Means a gas with low KH, you will have high solubility. Any questions, sir? Now compare only KH values. Compare only KH values, sir. Don't compare anything else. Compare only KH values. So I am writing yet temperature equal to 293 Kelvin. Yet temperature equal to 293 Kelvin. I am comparing only KH values which are in kilobar. Which is having highest KH. Just see the table, nothing else. Just to see the table, nothing else. Only at 293 Kelvin. I don't want remaining values. Right? So 293 value means can I take this one, this one, this one? That's all. Any other 293? Oh, see this also. All these 4 are 293. So what is the KH values order? Which is highest? Helium greater than. Helium greater than. Nitrogen greater than. Hydrogen greater than. Correct? Correct or not? Now tell me which gas is readily soluble in water at 293 Kelvin. Oxygen is more soluble than. Hydrogen more soluble than. Nitrogen more soluble than helium. When you apply same pressure and same temperature, the temperature should be kept constant or not? So pressure also should be kept constant. Then only this is the order of solubility. Clear? Respond. Any question? Now I am taking another thing. Point number 5. Yet temperature T equal to 298 Kelvin, sir. Here also I am comparing KH in kilowatt. Here also I am comparing KH in kilowatt. Now compare, sir. In 298 Kelvin, I don't want remaining all values. Only 298 Kelvin values, means only these. Correct? All these are at 298 Kelvin, no? Yes. 10 power minus 5. 10 power minus 5, yes. Now tell me, what is the order? Tell the order, sir. Your table is there. Which is having higher value. Argon greater than. Argon greater than. Carbon dioxide greater than. Vinyl chloride means, can I write like this? CH2 double bond CHCl. Vinyl chloride greater than. Methane greater than. Formaldehyde means HCHO. Correct? Formaldehyde. Right? One old JEE mains question, one old JEE advanced question. Understood? So they created question tough. Problem is, everyone said this question as toughest question. Reason, they have not studied NCERT. In NCERT, they gave the table perfectly. From NCERT table itself, in JEE advanced, they framed the question. Which among the following is correct order of KH values at 298 Kelvin? They gave these options: A, B, C, D, A greater than B greater than C greater than D, A greater than D greater than C greater than B, and so on. This is the correct answer. Reason? Data is already shared in NCERT. Right? Response, sir. Any questions, sir, in it? Say something.
No,
Do you
sir.
have any questions in it?
No, sir.
No, sir.
Now, if you have NCERT textbook, you will find some questions related to Henry's concept. I think there are 4 questions in your NCERT textbook. 3 questions in your textbook in one box. Sorry, 2 questions in one box. 2 questions in the back of the chapter. Totally 4 questions are given based upon Henry's concept. Almost every year, these 4 questions are given as a question in JEE mains. Every year they are given. Every year people will write wrong only. We have different phases, na? Phase 1, 8 papers. Phase 2, another 8 papers. Our total is 16 papers. In these 16 papers, for sure they will give all these 4 questions. For sure everyone will write wrong. Simple reason. They are not studying NCERT textbook properly. Now, sir, question, start. Give me the question. Even wherever you have, you open it and or I will search in internet. Henry's law, numericals from NCERT. Yeah? What, man? Shall I type in this way? I can open the book. NC. I think I have that book. I have the book. NCERT textbook I have. I will open the book directly. Desktop. NCERT. Solutions and colligative properties. So directly the table only came. Huh? Just now I copied the table from Google. Same table. Whatever I have discussed till now. This is chapter name. Solutions. Right? Solutions are homogeneous mixtures. We discussed this or not? Whatever I have discussed, every point is here. Gaseous solutions, liquid solutions, solid solutions. So solution may be in any phase. We discussed that point or not? But they gave different examples, nothing there. Next, expressing concentrations. Already you know, percentage weight by weight, percentage weight by volume, volume by volume, molarity, normality, molality, mole fraction, formality. Already you know that. So I skipped this part, right? After this, methods of X molarity also. Numericals related to molarity. Now what they give? So I started the discussion from here. Under that, they started with solubility of solid in liquid, but I started with solubility of gas in liquid. So I'm going there. Solubility of gas in liquid. Under solubility of gas in liquid, they explained about, right, directly proportional to. Correct? They plotted a graph, partial pressure of HCl versus mole fraction of HCl in cyclohexane. They have not given water. They gave cyclohexane. Reason, sir? If they have given water, partial pressure of HCl and here mole fraction of HCl in water, then I should not draw the graph. Because Henry's law fail. Correct or not? So HCl must be sparingly soluble in that solvent. That's why they have changed the solvent too. So in cyclohexane, HCl is readily soluble or not? No. Then only you will get a graph in this way. So Pa is equal to Kh into mole fraction. If I extend this graph, it will touch somewhere, right? Now tell me, at this point, I took this value on y-axis and this value on x-axis. If I divide those two values, what I will get? Kh. I got pressure value and I got mole fraction value. Pressure by mole fraction value gives the dot Kh. So they gave Kh values. Correct or not? Response, sir. Right. So I am copying this formula. Question. Solve. Solve, sir. Solve. Read the question carefully and solve. If N2 gas is bubbled through water at 293 Kelvin, how many millimoles of N2 gas was dissolved in 1 liter of water? Assume that N2 exerts a partial pressure of 0.9787 bar. Given that Henry's constant of N2 gas is 76.48. So see the units of Kh. As its units is kilobar, my formula of Henry's constant is P equal to Kh into mole fraction. If I give different unit, I will use different relation. Understood? Any questions in it? Solve, sir. So Kh is equal to 76.48 0.48 kilobar. Or I will write as into 10 power 3 bar. Response, sir. Correct? Therefore, partial pressure of N2 equal to KH into mole fraction of N2. This will be the formula. Correct, sir? Because of this will be the formula. Do they give partial pressure? No. 0.987 bar is equal to KH 76.48 into 10 cube bar into mole fraction. What is mole fraction? Number of moles by total number of moles. Correct? So instead of mole fraction, what I am writing? Number of moles of N2 divided by number of moles of N2 plus number of moles of water. Correct? Response, sir. Say something. Correct or not? We are dissolving that in water only, na? Right? Now tell me, what is number of moles of water? Here also see this very carefully. I will write this value as, I am writing this value as equal to number of moles of water only. Why, sir?
Sir, where
Henry's
the
law is
concentration of
applicable for
sodium?
what condition? Sparingly soluble gas. Means amount of number of moles of gas must be negligible when compared to number of moles of gas will be negligible when compared to number of moles of water. And sparingly soluble means it is less soluble. Less soluble means number of moles of gas in water will be less. If this is less when compared to N of H2O, then what is this denominator? Equal to N of H2O only. Correct, sir? So that's why I am removing this and I am writing directly N of H2O in denominator. Any questions, sir? Response, sir. Sparingly soluble. Sparingly soluble. Therefore, N of N2 plus N of H2O is approximately equal to N of H2O. Will you understand? Sir, I don't want, I want 100% accurate answer. Then you are heading. Solve it. You want 100% accurate answer, na? Then substitute N of N2, N of H2O, you will get some quadratic expression. Find roots of that quadratic expression, find the answer. Your choice. Correct? Say something. Huh? Tell sir, what is number of moles of water? Given 1 liter of water. 1 liter of water means how many grams? 1000 grams. 1000 grams means what is its number of moles? Weight by molecular weight. Correct? Number of moles of water is weight by molecular weight. Given weight is 1000 grams, molecular weight of water is 18. So number of moles is 1000 by 18. Correct? So 1000 by 18 means can write into 18 divided by 1000. Respond. Can I use like this? Let's say something, man. Then can I cancel this 10 cube and 10 cube? Then can I cancel this bar and bar? Therefore, number of moles of N2 equal to. Say something. Equal to 0.987 divided by 76.48 into 18. Moles of so I will write into 10 cube moles, millimoles. Response, sir. Because they want answer in. I'm converting moles to millimoles. This is number of moles into 1000 millimoles. Right? Find that value. 987 divided by 76.48 into 18. Approximately 10 times. 15 times. No. 13 times. 13 by 18. Okay. 12 by 18. 2 by 3. 0.67. Answer must be close to 0.7. Check the answer. Point over.
Sir, it's-
0.666.
Sir,
Yes,
it's
sir.
10 power 3 or 10 power minus 3, sir.
Madam, I am converting moles to millimoles. Arre. I
Okay,
want to
sir.
convert liters to milliliters. I got 1 liter as the answer. And how many milliliters? 1 liter means how many milliliters? 1000 milliliters. Correct or not? I got answer as moles. How will we convert into millimoles? By multiplying with 10 cubes. Right? Arre, say something. Do they give same answer or not? Check the answer, sir. Point 716 millimoles. Right? Say something, man. Yes or no? Any question? Hmm? Sir. Madurai one batch. Today I am in class around 8:30. I am also in class. Can we meet tomorrow at Madurai one branch? Madurai one means Chokikulam branch. Chokikulam branch. Okay, okay, I know. One great Akash. Yes. Tomorrow I will have a spotlight from morning 9 to evening 7. After 7 I will be at Madurai Kalavas. We can tomorrow after 7 we can meet, sir. By 7 o'clock we can meet. Yes, sir. Yes, sir. Yes, sir. Please. Yes, sir. Sir, we will do one thing. We will see. Right. Yes. Good. Saturday also don't be school. Yes. Sunday the option. Yes, that's. Sunday leave. If she want to come on Sunday to branch, open. Yes. She has to bring her car. As of now, she can come to. So then she will come to Kalavas. Batch will be formed at Kalavas or not, I am not aware. As of now, it's Mangalore, we are doing it. From many years, we are doing it. Kalavas this year only we are. Yes, yes. 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 Actually, I am not aware of this. Tomorrow itself we will discuss in faculty because I am not sure about it. Yes, sir. Definitely. What the answer or not? So what is the answer? Say something, man. 0.7 approximately millimole. Over. Shall we solve one more? Don't expect any bride. Huh? I won't give it. So don't even expect also. Yes, madam. Solve. Solve. H2S, a toxic gas with rotten egg-like smell, is used for qualitative analysis. If the solubility of H2S in water at STP is 0.195 molal, calculate in this constant. Solubility of H2S at STP is 0.195 small m. Small m means molality, molal. So 0.195 molal. Then what is Henry's constant value? What, sir? Solve. Quick. I need to start next topic also. Solubility of liquid in liquid also I need to complete. If you are interested in solubility of liquid and liquid, I will make it more complicated. If you are interested. For example, things like this. I have kept a bucket of water in this room. First drop of water when it is evaporating. First drop of water when it is evaporating. What is the mole fraction of water vapor and dissolved gases present in water in that first drop of it? Are you able to understand? You have soda water, right? Soda water and carbon dioxide. If I keep that cool drink water here, gas tries to escape, right? In the first bubble of gas escape, what is the composition of carbon dioxide? What is the composition of water vapor in it? How to carry? I will discuss if you are interested. Mathematically, we will solve. We can solve numerical also. We can use calculus there. If you are interested, I will bring calculus, thermodynamics. Everything depends upon you. If you are okay, I will bring. Otherwise, whichever is present, we will discuss. Your choice. Done. Say,
Sir,
hey,
5.12, sir.
1 point.
5.12 atmosphere. 5.12.
Hey, don't tell the answer by checking from NCERT textbook.
Sir, no, sir.
Good.
5.12 atmosphere per mole, sir.
He is saying 5.12 atmosphere per mole. He is giving that as the answer. Let me solve. What do you mean by molality, sir? Molality means moles of solute per kg of salt. Correct now? Molality means moles per kg. Correct? So molality means number of moles of solute per kg of solid. So what is the meaning of 0.195 molal? Can I write 0.195 moles of H2S gas, right? In 1 kg of water. Can I write in that way? The molality means moles per kg. So 0.195 moles of H2S gas in kg of water. Kg of water I am writing 1000 grams. Correct? Means, can I write this as From here, can I write number of moles of water equal to 1000 by 18? Can I write this? From here, number of moles of water can I write as 1000 by 18? Or weight by molecular weight. Number of moles means weight by molecular. Molecular weight of water is 18. 1000 by 8. Correct? Say something. No. At what pressure, sir? Given STP. STP means what is pressure? One atmosphere. Correct? Or okay. 1.01325 into 10 power 5 Pascal. Say something. Correct? Array, reason 1 atmosphere equal to 1.01325 bar. 1 bar means 10 power 5 Newton per meter square, which is nothing but equal to 10 power 5 Pascal. Correct? So what I will write? Therefore, 1 atmosphere is equal to kH into mole fraction of H2S. What is mole fraction of H2S? 0.195 divided by 1000 upon 18 becomes into 18. Correct, sir? Correct, sir? Means kH equal to, bring this to this side, 1000 upon 18 into 0.195 atmosphere. Correct, sir? The unit of kH is atmosphere, no. So what is the value? 1000 by 18, 55.56. 55.56 means I will write as a 555 divided by 1.95, approximately 2. 555 by 2. How much? 555 by 2. 1000 by 18 means 55. Huh? 55 means I will write as 55.5 as 555. 555 divided by 1.95. Approximately I am writing as 2. 555 by 2. Where I am getting 5.12, man? I am not getting 5.12. I am getting 200 and
Sir,
200 and
made-
something. Correct? 260 maybe, close to 270. 277 something atmosphere. Check the answer. Check the answer. Okay, I will check the
Sir,
answer.
I am getting 285, sir.
285, whatever it may. Oh, I don't have answer, madam. Yeah. 282, huh? Yes. Check the answer. Check the answer. Let them check the answer. Question number 2. You want question now? Question number 2.6. Question number 2.6. Hey, at the last review. Question itself. Not here. At the end of textbook. In book bags. No, that is. So these are index questions only, na. So they should give, na. So means in my book also at the end of the chapter it should be there. Let me check then. There, 2 point. Not there.
So only for some question they have given, sir.
Then how can you know this? Google it. Type it in Google and find it. Hmm. 280 282 is the answer given. How much we got, sir? Whether this answer is exactly 282 or not, take it. For sure. We got 277 something now. So you will get it exactly. So 1000 divided by 18, it is 55.55 divided by 0.195. 284.9. 285 I got. What they gave. How? Answer should be 284.9.
Sir, in that they have substituted the partial pressure as 0.987 bar, sir.
They substituted partial pressure as?
0.987 bar.
Oh, they substituted the answer in bar. Means they got the answer as 282 bar. I got the answer as atmosphere. Correct or not? Conversion. Bring that to this side, man. Oh, means you are saying 0.195 if I add in denominator. Then change is negligible. Change is negligible only, na? It doesn't change much. Response, sir. Or they might have done one more thing. Listen, if you remember, while we discussed in class 11 first lecture, I told you something about STP and NTP. Do you remember? What is STP? Define STP. Okay, standard temperature and pressure. What is pressure? What is STP pressure? 1 ATM or 1 bar? Up to 1985. Since 1985, I told you something. Yes, na? Bar only, na? Don't trust me. I will show you. STP. Wikipedia. What it is saying? Standard listen, sir. Please. Definition. In chemistry, IUPAC changed its definition of standard temperature and pressure in 1982. Until 1982, STP is 273.15 Kelvin and 1 atmosphere. So in our books, we are following that. But in 1982, they changed it. Now, what is 1 STP? 1 bar and 273 point something Kelvin. Correct? So at STP, what I have to take here, instead of 1 atmosphere, I have to take it as 1 bar. If I substitute that as 1 bar, then what is my units? 284.9. 284.9 bar. Means what is this into atmosphere? 1 atmosphere means these many bar. They give the answer as bar, but my bar is 284.9. That is my bar. This is my answer. Right?
Sir.
No. Come to next question. Yes, sir.
Sir, even if we consider it to be atmosphere itself, then also we should only substitute 1.01325, no, sir?
No, yes, 1.01325. That's why
Then
this
why did
when
they
you are
substitute
dividing, it may come closer to by 1 value or 2 values difference you will get.
But they substituted 0.987, sir.
They whatever they want, let them substitute, man.
Okay,
Maybe
sir.
in a textbook they might have given somewhere like that. In textbook they might have given something like that. Do you find any Henry's law constant questions here? This one is Henry's constant question. Yes, sir. That question you need to solve. This question. This question also you can solve. See, sir, how many questions they have given? Henry's law. Tell me, Henry's law is important or not? I will copy those questions also. Take screenshot of it, and by tomorrow's class, you have to solve all those questions. Yes, sir. Henry's law is over. Right. Right, sir. Listen. Take screenshot of it. Solve all these 3 questions by next class. I think my next class on Friday. Yeah? Friday, both classes are chemistry again. Right? So you have time up to Friday. By Friday, you try to complete all these 3 questions. If you are unable to solve, I will solve on Friday. Right? Shall I go to next concept, sir, then? Right? Now, before going to go further, listen carefully, sir. Listen very carefully. I am plotting a graph between partial pressure of gas A versus mole fraction of gas A. Then according to Henry's law, what should be the equation? PA equal to KH into mole fraction of A. Y equal to mx plus 0. Means intercept is 0. Slope equal to KH. So graph must be a straight line, correct? And having a slope equal to KH. Now see this. I am saying XA value is approximately 0 here. I will not write 0. I am writing approximately 0. Reason? Mole fraction equal to 0 doesn't exist. Right? Now, what is the maximum value of KH, XA?
1.
So maximum value of XA is 1. When XA value approaches 1, what happens to this value? When XA value is 1, what is this value? Correct?
KH.
Any questions in it? Now, I am writing one more also. Observe both carefully. I have given something in this graph. First straight line everyone will understand because we discussed about Henry's law. Second equation also you will understand after 10 minutes because I am going to discuss about Raoult's law. The problem with this, when you see real gas plot, when you plot a graph for gas in reality experimentally, you will never get either above line or you will never get below line. You will get curve which is present in between both. Are you able to understand? In reality, in reality, if you plot a graph, you will get this graph. You will get graph like this. You will get a curve, right? But when you see theoretical formulas, you will get either above or below. Why it is happening? Whether KH is changing to PA0 or whether PA0 is changing to KH, that we need to discuss, right? Okay, well, remind me about this graph after completion of rounds. Then I will explain this graph, why we have to plot that graph. Very, very important graph. If you open your Akash target booklet, go to 3, what we got as step 3. In that, there is one more than one answer type question based upon that graph. If you have your target booklets once open, not there. I think I have. Step 3. Page number 103, question number 9. This is that question, sir. JEE advanced question. Have you seen that graph there? How the graph is? Whether that graph is as the curve given here. So to understand that graph and that curve, one small logic is there. If you know that logic, if you crack that logic, that question is nothing, waste question. If you are unable to crack that logic, damn tough question. It is more than an answer type question. Understood? So we will crack that logic after completing Raoult's law. Right, sir. Now I am taking next side heading, sir. What is the side heading? Solubility of liquids in liquid. What is the meaning of it, sir? What is the meaning of it, sir? What is solubility of liquid in liquid? What is the meaning of it? Less volatile solute in less volatile solvent. Any questions? Right? Let us talk. To understand this, you need to know some small basic information. Small basic, right? You know vapor pressure. What do you mean by vapor pressure? Define vapor pressure. What do you mean by vapor pressure? Okay, listen, I am explaining vapor pressure again. Means again, I am not starting the topic, information. Listen, sir. Vapor pressure means pressure exerted by vapor on surface of its liquid at equilibrium. Pressure exerted by vapor on surface of its liquid at equilibrium. What is the meaning? What is the meaning, sir? Are you able to see any droplets on the top of it? Right? If I take any water bottle which is half filled, and if I keep it in sun for some time, sunlight for some time, or if you leave it undisturbed for one day inside this room itself, will you see some moisture content on the top of the bottle inside? Will you see it or not? Some water droplets on the top of it, right? Correct or not? Why? At this temperature, this liquid is absorbing heat energy from surrounding. By using that heat energy, liquid molecules are moving randomly. While they move randomly, they make collisions with each other, right? During that collisions, the liquid droplets or liquid which is present on the top layer will experience more collisions from bottom, and their energy enhances and they will escape from the liquid and convert into vapor. Those vapor molecules move randomly. When they are moving randomly at some instant of time, they may come in contact with the liquid again, or they may make collision with wall of the container. When they make collision with wall of container, what happens to their energy? When they decrease their energy, they will convert into liquid again, and that liquid will form as a drop. Right? At any instant of time, liquid is trying to convert into vapor. Vapor also trying to convert into liquid, and both will reach equilibrium at certain point. At that equilibrium point, some vapor will be present. Pressure exerted by that vapor is called. Now read the statement. Pressure exerted by vapor on the surface of its liquid. If I take water, pressure exerted by water vapor on water when there is equilibrium, rate of evaporation, rate of condensation, both exist. Both reaches equilibrium. That pressure is called vapor pressure. If I increase temperature, what happens? Or if I am heating it, what happens? Liquid converts into vapor. So amount of vapor inside it increases. Then what happens to pressure there? Increases. If I decrease temperature, decreases. If I don't change temperature, it doesn't change. Clear? Any questions in it? So I am writing it in simple words. I am writing. Liquid is trying to convert into vapor. At the same time, vapor is also trying to convert into liquid. At certain point, every reversible reaction reaches equilibrium after certain time. So this also reaches equilibrium after certain time. It is reaching equilibrium after certain time means what happens? At equilibrium, rate of evaporation becomes equal to is equal to rate of condensation. Response, sir. Or we call it as rate of precipitation. Rate of what is difference between vaporization and evaporation? What do you mean by vaporization? What is mean by evaporation? Vaporization occurs at, evaporation occurs at. That's how I am drying clothes. How we are drying clothes? Vapor, water evaporates. Right? If I increase the temperature up to 100, there is phase change. During phase change, at boiling point, then I call that process as vaporization process. Clear? Are you able to understand now? Rate of evaporation is equal to rate of condensation, not rate of vaporization equal to condensation. Why, sir? Vaporization happens at boiling point. At boiling point, do vapor will convert into liquid or liquid only converts into vapor? Liquid converts into vapor, but not vapor condenses to liquid, na? So backward is not there, only forward is there. Then equilibrium is not there. Clear? Understood? Any questions in it? When these two are equal, can I write this liquid and vapor as H2O liquid for our convenience and H2O gas? Can I write it for our convenience? Then what is equilibrium constant Kp equal to? Concentration or pressure? Kp. is nothing but equal to pressure of H2O divided by 1. Liquids. For liquids and solids is activity 1 when compared to gases. So I will write Kp equal to P of H2O. What is Kp? Equilibrium. Again, equilibrium. Equilibrium. What is Kp, man? Equilibrium. Constant. What is it? Equilibrium constant means Kp is, means P of H2O is. So P of H2O is constant. So whenever it reaches equilibrium, pressure becomes, that constant pressure is called. Any questions in it? Right? If I plot a graph, between rate versus time, initially I have taken water in this bottle, only water in this bottle. I left it undisturbed. Just that bottle is empty. I poured, I took a half of the bottle filled with water and I closed the bottle. What happens first? Do evaporation start first or condensation start first? This bottle is empty, man. Nothing is there inside this bottle. Now I have taken half of the water filled with water. And I have capped it, sealed it, closed it. Now what will start first? Condensation will start or evaporation will start? Evaporation will start. Reason? Only water is there. There is no vapor initially. Initially only air is there. Right? So rate of evaporation starts. So at a time t equal to 0, what is there? At a time t equal to 0, evaporation is there. Condensation, 0, not there. Right? Now, if I leave it undisturbed, do evaporation keep on increasing or evaporation is constant? I am repeating the question. I have filled that bottle up to half of it and leave it undisturbed. Evaporation is there, right? So, do that evaporation is constant? It is evaporating constantly, or it keep on increasing, or it keep on decreasing? What happens? Constant. Reason? As long as outside temperature I don't change, amount of heat going into the bottle remains constant. Amount of heat going into the bottle constant. Amount of water converting into vapor remain. So as long as surrounding temperatures are constant, rate of evaporation also constant. Clear? So what about rate of evaporation? What about rate of condensation? Initially 0, but as the time proceeds, amount of vapors keep on increasing. Then vapors molecules move randomly and they make collision with walls as well as liquid. When they make collision, they make condense. So what happens to rate of condensation? Keep on increasing. Till what extent it will increase? It increases till it cannot go beyond that. Reason, sir? If it is going beyond evaporation, what happens? The first statement itself is wrong. It will never evaporate. Right? Think. If a rate of condensation is crossing evaporation, means after a certain time, only condensation is there. There is no evaporation. Without evaporation, how condensation will start? Correct or not? So it cannot cross evaporation. Always it can reach maximum of. Respond. No.
Yes,
At
sir.
this point, both become equal. So this is the time when it reached equilibrium. That's why I call this time as T equilibrium. And here, rate of evaporation became equal to rate of condensation. Correct, sir? Any questions about that graph? Right? When this condition is reached, whatever pressure present inside that bottle, that pressure is called vapor pressure. Are you able to understand? When this condition is reached, so I am writing at time t equal to T equilibrium, rate of evaporation equal to rate of condensation, then P exerted is called P of H2O. We call it as vapor pressure of H2O at that temperature. Any questions, sir? Online, do you have any questions in this?
No,
No,
sir.
sir.
No, sir.
Clear? Absolutely clear? This is the room. Earlier, I have to can bottle and half of water. Now I am taking this room and I kept a bucket of water. Right? Volume of room is constant. Temperature of room is constant. Then rate of evaporation is constant. Then rate of condensation also becomes constant after certain time. Then in this room, air will be saturated with vapor. Pressure exerted by that vapor is called vapor pressure at this temperature. Right? Now, instead of having a bucket of water, I throw that water in the floor and I throw the bucket out and lock the room. Now, what happens to vapor pressure in this room? Observe, understand this carefully. First case, I kept a bucket full of water. Second case, I throwed water inside the room and I closed it. Now, what happens? Do vapor pressure changes or not? Do vapor pressure changes or not? Changes, huh? Not changes, huh? Say something. Doesn't change. Why? Whether I keep a bucket of water in this room or whether I throw the water in this room, the amount of heat taken by water remains constant. Then what happens to rate of evaporation? Constant. Then rate of condensation also reaches up to it and remain constant. Then pressure remain constant. That means vapor pressure is independent of all factors like surface area, volume, shape, everything. It is purely dependent upon heat, means temperature. Except temperature, no factor can affect vapor pressure of that liquid. Or if I change the liquid instead of water, if I throw petrol, then pressure changes. You would understand. If I change liquid, pressure changes. As long as liquid is constant, as long as temperature of the room constant, vapor pressure remain constant. Clear? Any questions, sir? So I am writing that point. Vapor pressure of a liquid is independent of all factors except temperature. Any questions? Here I am writing volume, surface area, shape of vessel, etc. Right? Will you understand, sir? Will you understand the meaning of it? Independent, dependent. Means a temperature will affect vapor pressure. Can I say vapor pressure as equilibrium constant? What is the relation between temperature and equilibrium constant? Clausius-Clapeyron equation. What is Clausius-Clapeyron equation? What is it? ln Kp2 upon Kp1 is equal to minus delta H of vaporization upon R into 1 upon T2 minus 1 upon T1. So, do temperature will affect vapor pressure or not? If it is affecting equilibrium constant means it is affecting vapor pressure. So, vapor pressure purely depends upon temperature. In this equation, it will differ. We call this equation as Clausius-Clapeyron equation. Now tell me, can I bring thermodynamics into solubility or not? Thermodynamics, I can create problems based upon thermodynamics or not for solubility by using it. Clear? Throw that aside. All this is nonsense for us now. Now you know what is vapor pressure. Right? Clear, sir? You know vapor pressure. Now listen. I have taken two liquids, sir. One is liquid A is mixed with liquid B to form a solution. I mixed liquid A with liquid B to form a solution. If I take only liquid A in that bottle, do it exhibit some vapor pressure? If I take only liquid A in a bottle, do it exhibit some vapor pressure? So let me consider that vapor pressure created by liquid A as PA0. If I take only liquid B, it also exhibits some pressure. Let me call it as PV0. If I mix both in solution, now what is the pressure? Whether it is equal to PA0 or PV0 or it is different. Different. So I call it as PS. What are these two? These two are vapor pressures of pure liquids. Correct? What is PS? Vapor pressure of solution. Correct? Respond, sir. Any doubt in it? So this is vapor pressure of no, we will not vapor pressure of solution. Later you will ask differently. Huh? Vapor pressure of solution. Now listen carefully. I mixed them. If I mix them, can I change number of moles of A, number of moles of B? I can change it or not. A will be less, B will be more. Or A keep on increasing, B keep on decreasing. As such, I can create different compositions. If I change the composition of A and B, what happens to PS? Changes or not? So can I say pressure exerted? This total solution's pressure depends upon how much amount of A you have taken, how much amount of B you have taken. Correct or not? Clear? Respond, sir. Any questions in it? Say something. Right? Now listen. Listen carefully. On changing composition of A, composition of liquid A, or liquid B, or liquid B, PS changes. Correct? But PS is always equal to pressure shown by A plus pressure shown by B. Accepted or not? Accepted or not? What is the difference? What is the meaning of it? If I change A amount and B amount, total pressure is changing. Whatever may be the total pressure is always equal to pressure shown by A plus pressure shown by B. Response, sir. Correct or not? Say something. Yes or no? Right? Or I will do one thing. You know Dalton's law of partial pressures. What is Dalton's law of partial pressure? Total pressure equal to sum of partial pressures. So total pressure PS equal to pressure shown by A plus pressure shown by B is equal to PS. Nothing but Dalton's law. Right? What is pressure shown by A? That is PA. What is PA? Partial pressure of A. Right? That is PA. Changes with XA. Accepted or not? On changing composition of liquid A or liquid B, total pressure changes. That is, PA changes with XA. Similarly, PB changes with XB. Accepted or not? Say something. Any questions in it? Right? Now I am writing that is PA is directly proportional to XA. Similarly, PB is directly proportional to XB. Accepted or not? If I take more amount of A, pressure because of A is also more. If I take more amount of B, pressure because of B is also more. And I have taken petrol and I have taken kerosene. Right? If I keep petrol inside the bottle, it creates its own pressure. If I take kerosene in a bottle, it also creates its own pressure. Now I am mixing both. When I am mixing both, I have taken more amount of petrol and less amount of kerosene. Then pressure is because of more amount of petrol or not? The amount of petrol molecules in vapor also will be high. So pressure in that total is because of more amount of petrol molecules or not? If I take more amount of kerosene, total pressure is because of more amount of kerosene. So pressure due to kerosene is because of amount of kerosene taken. Pressure because of petrol is because of amount of petrol taken. Correct or not? Any questions in it? Acceptable, right? If XA value is 1, then what is this PA value? If XA value is 1, XA value is 1 means I have taken pure A liquid only, nothing else. If a liquid is pure, then what is its pressure? PA naught. Means
PA naught.
when XA tends to 1, PA becomes equal to, I am writing the same. Limit XA tends to 1 or XA equal to 1, now what you will write? Tends to 1 or equal to 1? Tends to 1, now? Okay. XA tends to 1, PA is equal to PA naught. Accepted or not? Correct? Similarly, limit XB tends to 1, PB equal to PB naught. Accepted? Any questions in it? No questions now? Right? Therefore, I am writing PA equal to PA naught into XA, because PA naught is the maximum limit of PA. Accepted or not? Therefore, PA equal to PA naught into XA. Accepted or not? Say something. Or if you want mathematically, we will derive mathematically also. Understood, no? So PA equal to PA naught into XA. Similarly, PB equal to PB naught into XB. Response, sir. Response, sir. These relations are called as Raoult's law. We call that relations as Raoult's law. Simple. Right? Any questions in it? Now, what is total pressure P equal to? Therefore, P of solution is equal to PA naught XA plus PB naught XB. Accepted? Pressure of A plus pressure of B. Pressure of A is PA naught into XA, pressure of B is PB naught into XB. Response, sir. This is Raoult's law for solution. Then what is this one? This is Raoult's law for liquid B. This is Raoult's law for liquid A. This is Raoult's law for mixture of A and B. Correct, sir? Any questions in it? This is also obtained from these two only, na? Correct? Any questions? Now our game starts. We will play with formulas. Now see, sir. I am taking the heading liquid composition. Liquid composition. If I am taking only liquid A, I am taking only liquid A. What type of interactions present in it? Interaction between A molecules and A molecules. Correct? I am taking pure water. Then what type of interactions are present in it? Interactions between water molecule and water molecule. Correct? Right? So in pure liquid A, we'll have A interactions. If we take only liquid B, we'll have B interactions. If I take solution AB, what you will find? On mixing liquid A and liquid B. Now tell me, what you will find? I have mixed A and B. What type of interactions will find? AA interactions, BB interactions, and AB interactions, all the three. Correct? So on mixing A and B, you will find AA interactions, BB interactions, AB interactions. Correct, sir? Respond. Do you have any questions in it? All these three types of interactions exist. Any questions, sir? When only AA interactions are there, what is the pressure generated? PA naught. Pure A, PA naught. When only BB interactions are there, PB naught. When all the three interactions are there, neither PA naught nor PB naught. What is the pressure now? PS. The vapor pressure of solution. Correct or not? Say something. Right? So, no, yes, sir, carry it. So when I have taken all the three, what I will write? P total is equal to PA naught XA plus PB naught XB. Correct or not? Any questions in it? Here I call this as P calculated. And I call this as P experimental. I call this as P calculated and I call this as P experimental. Experimental value and calculated value both are equal. Right? Then I call this as ideal solution. Are you able to understand? PA naught into XA plus PB naught into XB. If I add these two, if it is equal to, practically when I do it, whatever the pressure obtained, practically obtained value and what I have done theoretically, both became equal. Then I call it as ideal solution. The meaning of it is, this is possible if and only if and only if all these interactions exist and are equal. A interactions will be equal to, BB interactions will be equal to AB interactions. If all interactions are equal, then experimental value and theoretical value becomes equal. Then only I call it as ideal solution. Means ideal solutions obey Raoult's law perfectly. Means ideal solutions obey Raoult's law perfectly. If there is any deviation between these three interactions, then formula fails. When formula fails, it is non-ideal solution. Non-ideal solutions do not obey. Means when I mix liquid A and liquid B, we are getting a solution. No? I separate that solutions into different categories, particularly two categories. When I mix them, that solution obtained may obey Raoult's law, may not obey Raoult's law. Clear? I am mixing two liquids, liquid A, liquid B. When I mix them, I got a new solution. That new solution may be any of the kind, any of the two kinds. One kind is it is obeying Raoult's law. Second possibility is it do not obey Raoult's law. If it obeys Raoult's law, mean what is the condition? AA interactions, BB interactions, AB interactions, same. If any of the interactions changes, it doesn't obey Raoult's law. Any questions? Do you have any questions in it? Understood or not? Online? Response, sir?
Yes, sir.
Yes, sir.
Yes, sir.
Right? Now see this. I am plotting a graph between mole fraction, vapor pressure. Here I am writing mole fraction of A equal to 0, mole fraction of A equal to 1. Now tell me, sir. If a mole fraction of A is increasing from 0 to 1, what happens to pressure exerted by A? Increases and reaches up to Yeah. A mole fraction of A, only I am taking A. If mole fraction of A reaches from 0 to 1, then when mole fraction of A is 0, what is pressure exerted by A? 0. When it equal to 1, PNR. So how the graph is? Can I write like this? Respond. Or I will write PA equal to PA naught into XA. Accepted, sir? Respond, sir. Accepted or not? If XA value is 0 means, can I write XB equal to 1? If XA value is 0 means, can I write XB equal to 1? Respond, sir. No. If XA value is 1 means, can I write XB equal to 0 here? No. I am going graph from this side to that side. When XB changes from 0 to 1, then what happens to pressure? Changes from 0 to PV naught, right? Now I am writing graph in this direction. Is there anything wrong? Assumption. Don't think that, sir, I have taken this height, that height, forget about it. Just I am making one assumption. Then this is PB naught. Now tell me what this line indicates. This line indicates PB equal to PB naught into XB. Any questions in it? No questions now. Observe this. At this composition, this is the composition, man. At this composition, you have certain XA value and certain XB value, correct? At this composition, when you have a certain XA value, what is PA value? This one? Are you able to understand? Again, I am repeating. I have taken this composition. At this composition, you have certain XA value or not? At this XA value, what is pressure due to only A? PA. So at this XA, what is pressure exerted by A? PA. Right? At the same position, you have certain value for B also. Correct or not? Then what is pressure due to B now? At this position. This is PB now. Correct or not? So I am writing like this. This is a PA value. And this is PB value. And this is the composition of liquid A, comma, liquid B mixture. Accepted or not, sir? Is it accepted or not? Then at this point, what is total P? At this point, what is total P? PA plus PB, correct? This is PB value. If I keep this value here, are you able to understand? I am keeping this value above this. Then this point is total pressure. Yes or no? Correct or not? Total pressure P equal to PA plus PB, na? This is PB value. This is PA value. What is PA plus PB? This is P total. From here to here becomes P total. Correct? Huh? Same way, at this point, this plus this. At this point, this plus again this only. If you join all these points, you will see a line like this. Are you able to understand, sir, what I want to convey? Are you able to understand what I am trying to convey? Right? So now tell me what this line indicates. What? P total, which is equal to PA plus PB. Acceptable or not? Old JE advanced. They gave this value as some value. They gave this value something. They asked you, then what is P total? What do you have to do? Common sense. Just add over. Correct or not? But don't think that's so only that one. The question was a little twist. The twist is at a particular composition, PA becomes equal to PB. At a particular composition, PA equal to, and both lines will meet definitely at some point, no? What is that composition? That is the question. Are you able to understand? What is that composition? They gave PA not value, PB not value. At what composition you will get PA becomes equal to PB? That is the question. But you understood that idea or not? Clear? Any questions, sir? Right? Keep that aside. Will you understand anything of about this? Will you understand, sir, if I write something like this? A, B, C. What do you write? A is always equal to. Correct? Are any questions in it? No, no. Here I have made one assumption. What is that assumption? In given graph or from given graph, what is the assumption? What is the assumption, sir? PB naught is greater than PA naught. Correct? From the given graph, I made one assumption. What is that assumption? PB naught is greater than PA naught. What is the meaning of it? Which will convert into vapor readily. I cannot always write like this, man. I can write PA naught here, PB naught here also. What is the meaning of it? Which is converting to vapor readily? B. Means can I write B is more volatile than A? Correct? Therefore, liquid B vaporizes readily than liquid A. Correct? Vapor pressure is more, man. Vapor pressure is more means it is converting to vapor more. That's why vapor pressure of B is more. If the graph is ulta, then A is more volatile than B. Correct or not? Now, B is converting to vapor readily means what is the boiling point of B? What is boiling point of A? Which is having more boiling point? A. That is boiling point of B is less than boiling point of A. Accepted or not? Right? So we call this one as ideal solution. We call this one as ideal solution. Note, very, very important note, sir. I have taken 50 ml of liquid A, 50 ml of liquid B, and I mix it there. What happens to total volume? 100. Reason? Attractions between A and A, attractions between B and B, A and B are equal. That's why 50 plus 50 becomes equal to, if they are not equal, non-ideal. In reality, ideal solutions are, now, if I take 50 ml of ethyl alcohol, 50 ml of water, if I mix them, what is the total volume? 100% it is not equal to 100. If it is equal to 100 ml, ethyl alcohol plus water is ideal solution. Are you able to understand? Do water molecules, if it is ideal, what about boiling points? Equal. If it is ideal, right? And both I have mixed 50 plus 50 equal to 100 is possible if and only if both boiling points are equal. Then also it is possible or not? Response, sir. If both have same vapor pressure, then also possible. In reality, is there any two liquids have same vapor pressure, same boiling point, such liquids exist? The moment I say two liquids means every physical property for them will be different. Correct? Understood or not? Now, I am taking a note, sir. Listen. V experimental value is equal to V calculated. Means delta V equal to 0. Correct or not? What do you mean by V experimental, V calculated? 50 plus 50 equal to 100 is calculated. Experimentally, I mixed them and I found that value also 100. Then it is experimental. So calculated and experimental values are equal. Means it is. So for ideal solutions, what is delta V? Are you able to understand? No. P experimental is equal to P calculated. That implies delta P equal to 0. How I calculated P experimental? By conducting experiment I have done. How I calculated P calculated? PA naught XA plus PB naught XB. Then delta P 0. If both are equal. Similarly, delta H 0. Similarly, delta S greater than 0. Delta G less than 0. If all these conditions are satisfied, then it is ideal solution. That means it perfectly obeys Raoult's law. Example for such solutions. N-hexane plus N-heptane. Benzene plus toluene. Online. Time up, huh? Yes, ma'am.
So we are here, sir.
Right. Benzene plus toluene. Chlorobenzene plus bromobenzene. Carbon tetrachloride plus silicon tetrachloride. Ethyl chloride plus ethyl bromide. All these are examples of ideal solutions. So in next class, we will see non-ideal solutions. So do you have any questions, sir, in liquid compositions? All right. The moment you see non-ideal solutions, you will create one more type of solution called agioto. right? Agiotrope, right? So if you understand agiotrope or non-ideal solution, 60% of the chapter is over. Now almost 30%, 35% of chapter is over. Right? Almost. And totally 4 parts, man. 4 parts, 25, 25, 25, 25. Solubility of gas in liquid is already over. Liquid compositions, not half, maybe 1/3. Ideal part is over. If you understand non-ideal, nothing. Almost happening. Right? Very easy chapter. Okay. I will end the session. Notes, everything I will upload after completion of the chapter, sir.
Thank you, sir.
Thank
Yes,
you,
sir.
sir.
Bye, sir.
Thank you, sir.
Yes,
Thank you.
sir. Bye, sir.
Thank you,
Bye.
sir.